For the last couple examples in 3.5 day 1, we're going to focus on the inverse properties. Now remember that these equations, many of them can be solved other ways, but the inverse properties here it just gives us a way to demonstrate these inverse properties. But like I said, definitely there are ways to solve these with other methods. So if you find one that works better, you go ahead and do that. So here are the inverse properties. Basically, a log and an exponential expression of the same base undo each other. We looked at this one in an earlier section, but now we can also combine it this way: log base b of b to the x. Those cancel each other out and just get x out of each one. So we're going to be looking to eliminate certain pieces in an equation with these properties. The first example that we'll do with this one is like you see here. So we've got 1.06 to the x equals 4.1. Now it looks like just a simple little equation, but I'm hoping that by now you're not thinking about dividing by 1.06 on both sides. I hope you know it's more complicated than that, but I won't ask anybody to admit if they thought that way, because everybody does at some point or another, I suppose. So we've got 1.06 to the x and 4.1. Here's the base, 1.06. So if we have 1.06 as the base, then what we're going to do is we're going to introduce, this is an exponential, we're going to introduce a log of the same base, 1.06, and that will get rid of all this junk over here. Now if we do that, we have to do the same thing to the other side. So we're going to do log base 1.06 of 4.1. So that's the consequence here. But this side just becomes x. Over here, we would probably want to use the change of base formula to get this one, unless your calculator has the capability of doing it more easily. So we're going to do log of 4.1 divided by log of 1.06. That will give us our result for this equation, and it's about 24.2. Again, good idea to put that in there, to plug it in for 1.06. If we do that, see what happens. Okay, 1.06 to the 24.2 gives you about 4.09, which is awfully close to the 4.1 that you see in the original equation. Now we rounded it, so I'm willing to call that one good based on just a round off error.